Hello ladies and gentlemen, in this video we are going to solve binary tree pre-order traversal. So before you work on this problem, you should be familiar with the depth of search, 3 different ways of traverse a binary tree, which is in order, pre-order, in order, and post-order. So the pre-order traversal, I wouldn't go deep into that. I would just tell you what the pre-order means. So pre-order is basically you traverse the root first, then you traverse then you go to its left, and then you go to its right. So for example, if you're in A, since you're already in the root, you print that root and you go to its left. So you're on A, you go to its left, now you go to its left, B, but you're not going to print it because you are on a different node and you have to do the same thing here. So you just postpone the part, the A traversal, and then you do the same thing for B. So you try the root for B, which is B, and you print it. So it should be A, B, right? You're in the B, and then you try the left of B. Now you go to the left of B, it's D, so you have to try retry the same thing, and you postpone the B. Now it's B and A. A is waiting for the left to be finished. B is also waiting for its left to finish. So once you're in D, you try its left. Now there's nothing on the left, and now you in the root, which you print the root. First you're not gonna try its left. Before you try its left, you're already on the root. So since it's root to left, right, you print D first, and then you go to its left. There's nothing on the left. Now you go to its right. There's nothing on its right. So that means you're gonna go up to B. So now B, the left side of B, is done. Now, as we said, it's root, left, and right. So we already printed B, which was root. We went to its left and did the same thing. Now we have to do the right part. So once you go to the right, it's C. Now B waits again for C to finish. Now we do the same thing for C. We try its, since we're already in the root, we're just gonna print the root, and then we go to its left, there's nothing, and so on, and then we go back up, and then B is done. We print its left and right child, and then we go to A. Now A root part is done, left child is done. Now we have to go to its right, and then we print it. So we follow the same thing. All right. So how do we come up with a how do we come up with an iterative solution to this problem? As you okay, let's think about it. You are printing the root first, right? Because it's root left, right. So you are given A. So once you get A, you are printing it right away. And once you're printing it, it's basically once you print it, it means you no longer need it. So you already traversed this node, so you no longer need it. So okay, that kind of starts. You have to think about it like, if you already printed it, you no longer need it, but you need its left and right child, right? So now as we see, we are printing A, and then we're printing B and T, and so it's going kind of down here. So it's kind of it means that since you're printing the root first, you are going to put it on a stack. So put it on a stack, on top of the stack. And once you put it on the stack, you are printing it right away. So you're not gonna wait. You're not gonna put the left and the right child on top of it again. But since it's root left right, you're first gonna put the root in the stack, and then you print it. As I said, when you print it, you get rid of it, right? You no longer need it. But in order to keep track of its left and right child, you also have to put them in the stack. So that means we put the root in the stack, and then we pop the stack. Once we pop the stack, we are gonna add it to our response array. So the first traversal is A. We popped, and now we popped it. Now we traversed the root. Now I have to go to its left. In order to go to its left, I have access to this popped values left child, right? So I'm gonna put its left child in a stack, B, right? However, as you see there's a right k, right? Now if I just put a left in here and then put a k later, now k gonna end up on top, which would mess up the way we traverse things. So that's why it's important to put the right child first. So I'll put the right child first. So when I pop it, I pop it, I popped A, and I add it to response, and I take its right child and put it first in a stack, and I take its left child, put it in a stack. Now it's B and K, right? Now again, you see the same process. So we tried for A, we tried the root, we printed it, we went to its right. We didn't go to its right, we just stored its right, but we went to its left. Now once we go to its left, we're not going to print its left yet. Well, we are actually going to print its left because this is a new traversal, and this is a root again. So which means B is a root again, and then we pop it again. We pop B and we print it, and we take its left. We take its right first and put it here. So as you see, the most recent right is on the top of the stack, and then we take its left child and put it here on top of it. Now the right is here, right? Two rights, C and K. Now we printed B. Now we're gonna go to its left child, so which is on top of our stack. Now, so since it's on top of our stack, it's a new traversal here. We have to do root left right for D2. So same thing, we pop the D, and then we append it to the results, and then we take its right first. There's nothing right, so we actually gonna put none in here, and there's another none for its left. And what we're gonna do now, since it's none and none, we are gonna go. We have to end up here. So let me get you my solution. So, and then I'll show you how this thing is implemented. So, okay. This is the recursive solution. So the first thing when implementing it you have to do is, so if you have none, then you pop it again, right? So when you pop it, if it's none, that means you just you have to have a check. So you have to have, so if popped, if there is something, if popped is none, that it's just gonna skip it. It's gonna pop both of them. It's gonna pop none and both none, and then it's gonna try C. Once it gets to C, it does the same thing, right? It's gonna, since it's already in the root, it's gonna add it here. Now it's gonna go. You have to check its left. If it has a left, you have to first check its right and put it on the stack. If it has a right, and then put its left child on top of stack. So how do we implement this? Okay, so since you already know, we are printing A at the beginning because it's a root left right. So, and then we need to use a stack. So I would have response, and then stack, and in my stack I'm gonna put a root right away because I want to do a while loop. So I say while stack, and as I said, I'm gonna pop the root because I have to print it, and once I print it, I don't need it anymore. So popped equals stack dot pop, and you just have to remember that in Python, the list, the end of the list is top of the stack. And that's why you append. When you append, you are putting an item on the top of the stack, and when you pop, you are removing an item from top of the stack. Okay, so once you pop, you check if it exists. Like we said, there was none values, right? If popped, what you're gonna do, you first, so if there is something, then we append that to our response, right? we append the value of that root. So we popped A, and we appended its value, and then we are gonna add its right child first. It's important. You have to add its right child first, which to a stack. So pop.right, and then we have to append its left child. And yeah, now after that it does the same exact thing. It's gonna go to the top, and then we just return a response. Awesome. So now let's think about it. So let's go through this example using so we have a response which is empty. So the first thing, we at the beginning our stack has a right, a line 15. While stack, alright, so we're gonna pop A. If pop, once we popped it, it exists, it's A. So that means we are gonna add it to our response. So we are traversing it root, left, right. But now we have to have access to its left and right child. So we append its right child to a stack first, and then we put its left child to a stack. So we had the most recent one. So we tried root, left, right. So currently we are at left, and we do the same thing again. Since we have to do the same traversal, which is root, left, right, and since we're already in root, that means we have to print it. And in order to print it, we have to we don't need it anymore, right? So that's why we pop it, and then we put it in a response, and we're gonna put its right child first, and B has a right child C, and we're gonna put its left child. Alright, awesome. So now we are at D, right? Now we are at D, and we have to redo the same traversal for this root. So it's root, left, right. So in order to do that, since we're already in root, we have to print it. So in order to print it, we have to pop it again and put it in the response. And then I have to put its left and right to the stack. Now I will put its right first, because I'll get back to them later. So its right would be none, and its left would be C. Now we do the same thing, and we pop C, and we put it here, and once we put it in there, we put its right child first, which is none, and we put its left child first. Now we're gonna go back to the while loop, as you see here. We pop the none, and then if popped, it's just gonna skip this, and we pop this line 9, pop this one. Okay, which means we tried left of C, right of C, and then nothing, and then we get back to C. We've already popped the C2, so we don't need it anymore. Awesome. So now we are at so that's how you basically do it, and let me run the code. So awesome. So one output, there is a mistake here. Let me see what our problem is. So we have a root response, we pop it, and response popped out. Okay, so here I'm actually putting right and right 2 times, so I have to put a left here. Awesome. So I think this should work. Awesome. So we bit like 94.69%. And that's it for this problem. And yeah, just make sure you're very comfortable implementing in order, pre-order, post-order using iterative approach. Recursive approach is much easier to implement, but the iterative makes you think about, which is really good for problem solving.